Hello everyone, welcome back. In today's lesson, we're going to discuss about IoU. IoU, or intersection of a union, is a metric used in object detection tasks. It quantifies the overlap between the predicted bounding box, like this one in red color, and the ground truth bounding box, like this one in green color. That makes IoU a core evaluation criterion for assessing object detection models. IoU is a metric, as we said, and as a metric, it plays four roles in object detection models. The first role is quantitative measure of overlap. The second role is threshold for accuracy. The third role is integration into evaluation metrics. The fourth role is confidence filtering. The first role, quantitative measure of overlap. IoU calculates how much the predicted bounding box overlaps with ground truth bounding box. How much? So how much? How much is reflected here? Values of IoU range from 0 to 1. 0 means no overlap at all, and 1 means perfect overlap. Let me move this prediction bounding box away from ground truth. There's no intersection, as you can see, and the value for IoU is 0 because there is no intersection. But when we try to overlap to match 100%, let's try to match 100%. You can see how the value increases as I try to match two bounding boxes. Perfect. Perfect. The match is 100% and IOU is 1. Okay. Then the second role of IOU in object detection models as a metric is threshold for accuracy. What's that? In practice, a specific IOU threshold can be, it's not always, but in most cases, it's 50%. Let's say 50%. Based on this threshold, based on this value, we can say if IOU is above 50%, this is going to be a true positive. Like in this case, IoU is over 50%. It's one here. Then you say it's true positive. Even if I move the bounding box a little bit far, as long as it's 50% or above, it shows the intersection is a true positive. And a false positive, that's when the IOU is less than or below the threshold. Let's say, in this case, if we move the prediction bounding box a little bit far away, so that this makes the IOU less than 50%, and this means it's a false positive. You remember when we were running confusion matrix, we saw that false positive is when the model is seeing the object where the supervisor doesn't see it. This is where the model is seeing the object. It means the model is seeing the object where we don't see it, and that's considered as a false positive. The third role as a metric is integration into evaluation metrics. IoU is integrated into evaluation metrics. As we saw earlier, IoU, based on the IoU, we can find the true positive or true positives and false positives, and that's going to contribute into the calculation of precision and recall. In the previous videos, you remember the formulas for precision and for recall. So they are made up of true positive, true negative, and false negative. And also IOU is going to contribute to contribute in the calculation of MAP, or mean average precision, because as you know, MAP combines precision and recall across multiple IOU thresholds. For example, a MAP can be calculated at a range of threshold, for example, from 50% to 95%, and it will show how the model behaves or performs at that range. And also, as a metric, IO is contributing in confidence filtering. We won't discuss further about this because there is no presence of ground truth. We are going to discuss this in next videos. So, why IOU matters in object detection? Because it ensures the models not only detect objects, but also predict accurate bounding box locations. And higher IOU thresholds demand stricter alignment between predictions and ground truth, improving model quality. As you saw, to achieve this higher IOU, we tried to match, almost a perfect match, to match the ground truth bounding box and the prediction bounding box. So for higher IOUs, or for higher IOU value or values, the prediction is achieving a higher precision. Okay, so I just to let you know that the demonstration we're seeing here is the output of the code I wrote. This is the code I wrote for demonstrating what I'm demonstrating to you. Well, there's nothing, we're not discussing about the code. That's not the topic of today. So let's make calculations. Let's see how to calculate the IOU when you are in this situation, or you are given this situation. What do we have here? For ground truth, we have, let's say, x1g for ground truth is 299, 299. Y1 for ground truth is 400, 400. Then for bottom right, this is this point, and that's y1. Let's start by x1, no, x2 ground truth. It's 7 to 8, 7 to 8. Then y2 ground truth, that's 5 to 2. No. Then for prediction, we have this point, top left, x1 pre for prediction, x1 p or p, that's 315, and y1p, that's 433, and for the bottom right point, we have x1, we have x1 p, no, that's x2 p, because it's the bottom right. That's 750, then y2p is 550. So this is what's given. So let's go my calculations. So this is what's given, and this is exactly what we just typed. Now let's calculate the coordinates of the intersection box. We found the coordinates for ground truth bounding box and prediction bounding box. We're going to calculate the intersection coordinates. Okay, for intersection, let me come back here. The important points is this point, x1 and y1 for intersection, and this is x2 and y2 for the intersection. So how do we calculate this? You will be surprised that to calculate these points, we have to find the maximum value and minimum value for bottom right. Why this? Why this? Okay, for us, if we take this scenario, we really don't need these calculations. But for a computer, it needs to determine this value, which is maximum and minimum. Why? Let me explain that. See this scenario. For this scenario, but first of all, let me tell you, we count from top left. We count 0, 0 here. The 0, 0 coordinate point is here. It means if you want this point for intersection, let's look at x1. x1 here for this intersection is currently 315 because it's x1 for prediction bounding box, and y1 is this one. What if it was rather like this? Because this is also possible. What if it was rather like this? Now the intersection is starting from, it's determined, or the top left point of the intersection is determined by the ground truth top left point. Do you see? When it was like this, the intersection top left was determined by the prediction, but see, Now it's determined by the ground truth. That's for top left point. And what about the um, bottom right point? Now, the bottom right point is determined by the the ground truth. I mean, the top, the bottom right of the intersection is determined by the ground truth. But in the case when the intersection or the bounding box will be have this location, the prediction bounding box will be having this location. So as you can see, the this point, this top bottom right point of the intersection will be this one. So this is the reason why the we need to always find the maximum, the minimum, the maximum for the top left, the minimum for the bottom right. Does it make sense? Let's now that I hope you understand this. Let's go to computing the area of the intersection box. You have found those points, so it's easy to find the width and the height, because if you found these points, let's say if you got those points, it's easy to find the height and the width, and then the area is found in pixels, and because we already have the coordinates for the ground truth bounding box, we can easily find this area of the ground truth, and we can also easily find the prediction area. So since we have intersection area, ground truth area, prediction area, we can easily find the union area, which is this. Now, coming back to the formula of IoU, where we take the area of intersection and we divide it by the area of the union, we already have these values. We calculate them. We have the six something for intersection. It was calculated here, that 6 something, and IOU 66 something. It was calculated here. So we just make calculation, and this is the IOU. So the IOU is 55%. This is how the IOU of 55% looks like. Okay. So this is the end of today's video. I hope you understood how the IOU is very important. It's a very important metric in object detection, and I have guided you through the calculation of IOU. Of course, this calculation is done by the model, but as a programmer, as an AI engineer, you need to understand how these things work, because tomorrow you will be writing your own model, and you will need to know which formula you need to give it in order to perform the IOU. You need actually to understand how everything works. You don't need to leave it to the IOU and without knowing what's going on under the hood. Thank you. I hope you enjoyed this video. You can subscribe because I'll be dropping more videos. You can subscribe, and why not sharing if you liked it, and if it can help someone else, why not sharing it? And yeah, if you it's interesting and you want to encourage me to make the videos, you can also like it. Thank you. Thank you. Bye.